Hi everyone, welcome back. This is Lynn again. In this video, I'm going to talk about control flow, comparison operators, and you will learn about how to add branching to your program using the if-else construct. So the program runs or executes the code sequentially. It means that it starts from line 1 and goes to line 2 and so on. So it runs a program or the code line by line. And I mentioned previously that there may be a point in the code that there would be an instruction that is a test actually. So there may be a test somewhere here, and based on the answer on this test, the next code or instruction may be executed, or it may jump to another instruction or jump back here. So we do this. We can do this test using comparison operators. So let's say we have the variables I and j. Below or here are some comparison operators which evaluates to a Boolean. So for example, here I, or the value of I, is the value of I greater than the value of j. Then the answer here will be either true or false. So it will always be Boolean. And all of this operations can be done on int, float, and string. So the next one is greater than or equal, less than or equal, and then here we have the equality test. Take note that this is the equality test is two equal symbols, two equal sign, compared to the one equal sign, which is the assignment operator. So here is the value I equal to the value j is an equality test. It returns or it gives true if I is the same as j. And then the last example is not equal, or the inequality test. This is the exclamation mark followed by the equal symbol, equal sign. So this one is true if I, the value I, is not the same as the value j. For Booleans, by the way, we can compare this. Let's say we can compare I and j if they are both int. So int and int, float and float, string and string are possible. Int and float, comparing int and float is also possible. However, we cannot compare string and int and string and float. So these are the comparison operators, and these are also called often called relational operators. For Boolean, so if the values we want to compare are Boolean, we can use these operators, the not, and or. So the not is inversion. So not a, let's say a is a variable name with a Boolean value. Not a gives us true if a is false, and false if a is true. And a and b, where a and b are both Boolean values, gives us true if both are true, both a and b are true, and a or b gives us true if either or both are true. Take note that the keywords are not, and or. The table is here for and or, in case you would want to see the table. So now that we have Well, now that we know how to do tests, we can add tests to our program. So here we can now add tests here using the logical operator and or the comparison operators. And then at the same time, along with this test, we add branching, because depending on the answer to this test, we branch out. For example, if the answer to this test is true, this code or this block of codes or this group of codes, we also call this code block. This code block will be executed. However, if the answer to this question or to this test is false, this codes will be executed. So formally, that's to include that to a program or to a code, that's what we call the if-else construct. And the algorithm for that is if the answer to condition, where condition is a test that results to a true or false, therefore condition, it may be a conditional operation or logical operation. So if condition is true, do true block, or the block of code that has to be executed if the answer is true. Otherwise, do the false block, where false block is the code block that correspond to the lines of code that should be executed if the answer to this test is false. In Python, the syntax for the if-else is this: if condition colon true block, the block of codes here, or expressions here, else colon the false block. There are variations to the if-else construct. For example, here we have if, one if only. So if condition, there are lines of codes executed if this condition is true. So this is one or single if construct. So let's say we have this one. This is a diagram that that shows the flow of control. If we have this construct, so it goes this way. This lines of codes are executed, and then the program encounters this test or this condition. If the answer to this condition is true, the flow of control goes to this block of code, to this code block, and then after executing all the lines of codes in this code block, the flow of control goes here, and then this lines of code or code block is executed. If the answer to this is false, this is executed, this code block at the bottom. So this single if executes this additional code block. Okay, so this condition or this test decides whether this additional code block will be executed or not. Then another variation is the if-else. So we have here if condition colon and then the code block for true, else colon the code block for false. Okay, so graphically, if we want to see it visually, here is a representation of it. So the program runs, executes line by line, and then the program has a test or a condition. So this if-else construct gives two-way branching. So it gives us two choices. So If the answer to this test is true, this code block is executed. Otherwise, this code block is executed. So one of these two choices will be executed or has to be executed before the program runs this next sequence of codes or next lines of codes. So here we have two branching or two choices. Next, if we have more than two choices, we can use the elif. So this elif is so here is the syntax for if, elif, else. So basically, we insert an elif construct between the if and the else. So here, if condition is true, these expressions will be executed. If this condition is true, this will be executed. Else, this last block of codes will be executed. So visually, it looks like this. So the program runs or executes these lines of codes, and then we encounter an if condition. If the answer to this test or to this condition is true, this code block is executed. If this condition, second condition, is true, this code block is executed. Otherwise, if the answer to this is false, this code block is executed. Before this last code block gets executed, one of these three has to be executed first. So here the program chooses between one of these three. If we want to have more than three options or choices, it's possible. We just have to add more elif condition. So if we want to have 5 or 10 or even more, we can do that by adding more elif conditions. Also, take a look at this one. If the answer to this condition is true, and the answer to this condition is also true, this is chosen or executed. So it chooses the first code block that has answered true on a condition. So even if this is true, but if this comes first and it is true, so this first code block is executed. We also have nested if, or we can do nested ifs in Python or in any other language, programming language. So here, what is nested if? It's an if construct within an if code block here. So like in this example. And visually, it looks like this. So the program executes these lines of code and it encounters a test or a condition. If the answer is true, a code block has to be executed. And it so happens that this code block also has a test or a condition within. So here we have another test, and then if this one is true, this code block here, which is an inner if structure, so it's inside this block of the if, the bigger if construct. So if this is true, this is executed. Otherwise, goes here and so on. Okay, So this is what we call nested if. This construct actually it's very powerful. I mean, you can do a lot of things with if else already. Um, in Python, well, we denote a block of codes using indentation. So here you can see that this block, which has a color light blue, this have the same the lines here have the same indentation, meaning they belong to the same block. And in Python, the indentation or line indentation is very important because of this reason. And here you will see the line of code that has a darker blue shade. It means that it is an inner block here. So this is the block for this one, and at the same time this belongs to this bigger light blue block as well. So this property of Python, this line indentation actually is an advantage of Python because over other languages, because by just looking at the code visually, by looking at a page, you will see the blocks already, compared to other languages that use curly braces. So by the way, in programming, in coding, when you're starting to code, be careful with your indentation. And also here you will notice if x is equal to y. This 2 equal sign means the comparison operator is equal to, or the equality comparison operator. Always remember and be careful with the difference between the 1 equal sign versus the 2 equal signs. So 1 equal sign means the assignment operator, such as this, wherein we assign the value from here on the right hand side to the variable x, to the variable on the left hand side, compared to the 2 equal sign, which means we are comparing the value on the left hand side with the value on the right hand side. So let's try some sample problem. Let's say we have this problem. Ask the user to input an integer and output whether the number is odd or even. Well, how do we know that a number is odd or even, or an integer is odd or even? So an integer is even if it's divisible by 2, right? So first, I know what is our first step. First step is to know the input, if there's any output, and then algorithm. What's the algorithm? So the first step is ask the user, enter an integer, and put answer in num, in a variable num. And then second step is to check if the remainder of num divided by 2 is equal to 0. Tell user num is even. Otherwise, tell user num is odd. So let's go to our code. I copied and then pasted the algorithm here. And as our practice, we make this algorithm, we comment this out, and line by line, we try to write a code for each line. So ask the user, enter an integer, and put answer in num. So ask the user, input, enter an integer, and put the answer. How do we put the answer? We assign it to num. Next line, step 2, if remainder of num divided by 2 is equal to 0. How do we get the remainder? We can use there is an operator for this one. We can use the modulo operator. So the modulo operator gives us the remainder. If num divided by 2, num modulo 2 is equal to 0, what do? We tell the user that num is even. Next line, the last line of code. Otherwise, tell user num is odd. Else, colon, print num is odd. Okay, there you go. And then we run the program. The console says enter an integer. I want to enter 7. Oops. It says, oh, the error is not all arguments contain. Why? What is the reason why? Because, again, here, there. Yeah. Yes. Because input gives the program string. Therefore, this has to be casted or converted to integer. Now we save our program and then we run it again. And then let's input 7. 7 is odd. Is that correct? Well, I think so. Then let's run it again. Try to input 4. 4 is even. Is that correct? Yeah, I think so. Okay. Right? That's all for today. I hope you enjoyed the lesson today, because it's one of the very important lessons in programming. And enjoy the exercises and have a nice day.